Hey everyone, how's it going? This is Patricia here, and I am excited to see you today. It is the 11th of June. I'm coming to you live from San Francisco, 9 a.m. here. The sun is rising. Today we have a really fun online meetup, and it's with John Owings of Pure Storage. I'm super excited. I've known the Pure Storage folks for quite a while. It's a great company, beautiful logo. And so what we'll do before I hand him the mic is tell you a little bit about online meetups. These are showcasing ways that developers are using Traefik at companies to solve interesting technical challenges. I am the head of community for Containerize, and I represent the software Traefik, which is an an open source reverse proxy and an edge router. And also we have Mesh, our simpler service mesh. You'll want to go to Containerize and see what we're up to and keep your eyes on us. We are one to watch. We're a growing distributed team. And we also have a wonderful community and a community of Traefik ambassadors who are people who contribute to Traefik and write content and create a community around us. So if you're already using Traefik and you want to be a part of that program, please go ahead and get in touch with me, and I'll help nurture whatever you want to bring forward to the world, and we'll get it out there, and we'll give you a crown and send you some goodies and promote your work. With that, I'm going to say that we're going to take questions to John's session today, so please leave your questions in the chat box. And I'm going to pass John the mic and let him rock and roll, and we're going to have a good time here. So thank you very much for joining us today, and thank you, John, for your session. So we look forward to watching it.
All right. Well, sorry about, I shared my screen 1 minute too early, Patricia, so she's going to put a ding against me on there. But excited to be here right now. Hopefully the right screen is being shared that everyone can see my presentation. And my face is glowing orange because that's how we do things at Pure. Everything is orange, and that's how we roll. So my job at Pure Storage is really, I talk to customers that are looking at or exploring using containers. And so I've kind of gone across this spectrum of using containers in a way where it's gone from, dev test, stateless services, and all the way to now these persistent apps, which can be data pipeline, Kafka, those types of things, AI like Jupyter Hub, or just custom Python, TensorFlow, or even enterprise apps like SQL, like Microsoft SQL Server. And obviously that's why we're interested, because those apps need persistence in saving them. And so I talk to a lot of customers that are trying to figure this out and how to do it. They may have no experience whatsoever with containers, or they have, they've been using it for a while, but they only use it for stateless and they want to know how to do this. So I get to kind of share, what we can do, which is exciting for me. So before, though, while I did this, and I'll kind of take you through the story of how I, over the last couple of years, because I've been doing this role for 3 years. I've been at Pure for 6, but being able to kind of share with customers like how we do it, the first iteration of these demos, because everyone likes to see it work, right? So we built a driver, it's a CSI driver, and I'll get more into the details of that in a minute. But everyone wants to see how it works. And the reason why, I talked to Patricia about sharing how I use Traefik is kind of had to change the way I did demos, because I thought that they were very boring when they were just this. Hopefully everyone, this looks somewhat familiar, is that we have, CLI, and it's a, get pod, and, I'm showing them, the PVCs get created. And at the end of the day, yay, the PVC is created, right? And, maybe I'll come into our flash array GUI, which is the actual interface on the storage device, which is a physical hardware device, and I could show, hey, there's a volume. But that, the concepts don't match up, especially for people that don't know Kubernetes all day long. They don't, a PVC may be a very new concept to them. So after I show them that, I'm like, I'm done. And any questions, right? It's not an exciting demo. It does not really connect with people That's why the title, storage demos are boring until you can see the app. So I needed more. I needed to be able to present in a way that could show the app, no smoke and mirrors. It had to actually be real. And I do them all live. It's not pre-recorded, even though that would be easier because things do go wrong sometimes because I'm not awesome at typing. And they need to be repeatable and quick. So, I can't just go, hey, here's a demo, and then let's watch the screen for 60 minutes because everyone would drop on the phone now if I started to do that. So, and I didn't want to use port forwarding or node ports or anything like that. I did try that early on, and that was a little clunky in a demo in front of a customer. I wanted it to look polished and professional, so that way I could use a DNS name, boom, everything pops up and it's ready to go. And be able to show the network if needed. So if people said, hey, how do you do that? Or, how does this happen? Like being able to do this on-prem, with I don't have an AWS elastic load balancer or anything like that to be able to work with. So I needed something to fit all these pieces together and be within our labs where I have access to our physical equipment. And at that same time that I was going through this, I started playing with this tool on my Raspberry Pis called K3s, right? And hopefully everyone's heard of that. And it had a really cool Ingress built into it. And I was like, well, let me start researching this thing. And that's how I got introduced into Traefik and being able to use it. And so, I want to give credit. That's where that's how I learned about it. Like I wasn't Googling or anything like that. I was like, hey, this looks cool. And yeah, so, back to the demo, back to, how I do this, and kind of how this has changed, and hopefully help everybody see kind of how Traefik helps me show off what we do. So storage, obviously, in Kubernetes world, right? It started off as an in-tree kind of driver. It was obviously that's not scalable or not part of the community because if every storage vendor had to commit code into the main tree of Kubernetes, that would one, take too long, and two, it's not good. And so Flex Volume came out. That's actually where Pure Storage entered kind of into this Kubernetes market, is as a Flex Volume driver. And that, of course, is kind of fading away. I don't think they've set the exact date it's going to be deprecated yet. We still have a driver for that, but obviously all new effort is going into the CSI driver, the container storage interface, and how that works. So that's what I'm going to show when I'm going to get to the demo here in a second, and I'll show how that works and then how Traefik helps me. So when we were developing the Flex Volume driver, Kubernetes, it was probably 3 years ago. Kubernetes was a cool thing, but people were still kind of trying to decide whether they're going to use Docker Swarm or Kubernetes or even Mesosphere. Like there was a lot of choices. I think that they're getting narrowed down some. I mean, you can still use those other things, but more and more, I probably spend 99 out of 100 meetings talking about Kubernetes. Now, that CSI plugin lets us kind of integrate with any of those orchestrators and provide this extra layer of abstraction. So what we really want to do is get everyone out of the business of managing physical storage devices in arrays. So we have a couple of different products. You can see there different pictures of them. One that's cloud-based, and then two that are physical hardware, one called the Flash Array, one called the Flash Blade. And we want to abstract that, right? We want to take all the best practices that a storage admin would do to provide a volume to an application and do that for you. So that's where this container storage on demand comes from. So it's a little bit more than just, hey, here's a driver, it provisions storage. We want to be able to do a lot of smart decisions by default while we do that. And then with that abstraction is you can now just say, I want to run Elasticsearch, and I deploy the Helm chart and everything runs, right? Or I want to run Postgres, and all I need 100 gigabytes of very low latency storage for transactions, and it would provision to our pure block storage class, those types of things. Or maybe a CI/CD pipeline where you may have a combination of all that, and also using things like snapshots and clones and all kinds of fun things that kind of develop out of deploying software and being able to have that automated where now there's no longer a human interaction to provision that physical storage resource. And Pure Service Orchestrator really lives as a control plane only storage layer. And what it does is it's not in the data plane at all. So it's just orchestrating native tools. So if you're using Elastic and it's going to mount an NFS share, we're creating that, mounting it, doing all the commands there for you. So not in the data path. So some benefits of that is somebody deletes it, like they go, what's this pure-CSI namespace in my Kubernetes cluster, and they delete it. None of the existing connections to your applications will go down because it's control plane only. Of course, you won't get new ones, but you'll be able to keep on running with your application. And obviously, we work with lots of different flavors of Kubernetes, just like Traefik does as well, because at the core, it's that open API. And so no matter how any of the vendors wrap it, we can integrate. I want to give two examples of our customer. Well, one's internal and one's a customer that uses it, and I'll show you the demo. Internally at Pure, when we develop software, right, we push out lots and lots of tests. It generates this 27 terabytes a day, and we push all of this data through Kafka and Spark in order to get that right amount of QA done in that. It'll generate a JIRA, and so that the developers can fix the right bug, basically. So we don't need hundreds of QA engineers, but maybe just a couple to be able to fix these regressions and things that fail, those types of things. So we don't want to duplicate all that effort. And all this runs in containers, right? And because they actually built this 5 years ago, it was all manual. And here's all the shell scripting and all the horribleness that you would have to do to make it work, which is not fun, not very cloud native, obviously. So where Pure Service Orchestrator fits in is anything that needs that kind of mount point. It automates everything for you, right? So there's no pre-work to be done, no pre-provisioning. It makes all that for you. Same is, this is Elasticsearch and Prometheus. This is a customer that has a 7,000 node compute farm, and they basically needed a way to automate as they scaled Elastic and Prometheus and Kafka up and down. They wanted to be able to have that storage automatically scale up and down with it. And they wanted to have block, or they wanted to have NFS and object in the same device and have it be fast, right? So traditionally object is slow. Our FlashBlade device has fast, very fast, low all flash, very high performance object on-prem. And so that way they were able to ingest all the logs, and their comment is it just works. They don't worry about how the storage provisions. They just scale their clusters for Elastic and things like that up and down, and it just works. So that's the end done. So we hopefully get past the part of it, explaining what I do, and we can get to kind of what you're interested in. So I'm going to deploy in this demo CockroachDB distributed database. I think it's a nice one, mainly because I like to show off the app, and it has a built-in web UI. Which works very well with the Traefik Ingress. So I could show it off and show off scaling and how the storage connects to it and all that fun stuff. So that's the first demo. And we're going to actually take advantage of a topology feature that allows us to spread those distributed nodes across different, in my lab, they're actually racks, but I call them availability zones because that way the concepts map easier to what you do in the cloud or what you do within your data center. Then I'm also going to show a Go-based web application that has a MySQL backend, and I'm going to show the cloning feature and then how we can actually use the Ingress to kind of see both of those. So it's a double demo. So I'm super excited. So here it is. I also really I like to be able to show this to people, showing like, hey, there's more to it than just the storage part. So I could show, like in Traefik, I could kind of show my HTTP routers and things like that, so we can see what's going on as I deploy these applications. you can see I've already put the DNS records in so that they all point to a single load balanced IP. And so now when I deploy the app, it's going to just start up. So in addition, if anyone's super interested still, is all of this stuff that I'm doing today, I've put up on my GitHub page. It's 2 VCPs, and we'll send out, I'm sure Patricia will send out links and stuff like that. But that way, if anyone's interested in any of the deployments or YAML that I use today, they can totally just have it. So I like to share. And so we're going to launch CockroachDB. Actually, no, I'm not. So our driver's deployed via Helm, and it is a very easy install. It actually, all it requires locally is, we're now getting into the nerdy stuff, which is fun, is a values.yaml file with, you know, management IP address of the physical device, an API token. Now for that topology portion, I'm going to show off, I have a topology. So it's basically, I have, instead of availability zones for fun, I've changed it to dinner. So I'm either gonna have tacos or burgers, right? And I have 2 different arrays. So I have one in this subnet, right? And one in this one. So they're 2 different physical devices with their own API tokens. And so this is all I need to keep locally because the rest is stored in our Helm repo on GitHub. So pretty easy there. And when I install it, actually, let's uninstall it so you can see it install. It's very, very easy. While we're doing that, I'm gonna make sure, are there any questions or anything while I'm? No, good. We can save them for the end too. So this will not go the full hour unless I do something drastically wrong. So Helm ls, right? So there's nothing installed. To install it, all you need is a Helm install command. I give it a name. I don't put it in its own namespace just for ease of showing it off. This will just be pure CSI -f demo values. So just, all I do is point it at that values file, and it's going to deploy our application. Now, the reason why I'm using kind of like these extra apps, like the Go web app or any of that stuff, is our driver, our application is really cool, but it doesn't have an interface. It basically translates the REST calls from Kubernetes to our physical devices, right? It's a service that does that. And if you, we look at the pods, so I can see them up and running. So there's drivers that run on each worker node in my cluster, and there's also, you know, provisioner. So all it's doing is translating API calls between them, but it's also obviously very important, but it's really hard to show people every day. So now we're going to deploy an application, and we're going to deploy Cockroach first. And you can see here, if we scroll through it, there's some services and replicas. I'm going to have 4 because I want 2 in each availability zone. And we've just done a node affinity, right? So we're going to say, hey, make sure that I have pods in burgers and pods in tacos, because if you can't tell, I was super hungry when I was creating this demo. It's probably right at dinner time. And so the rest here, we scroll down in the storage piece, I'm telling it, hey, use this delay binding so that we can actually match the storage to be local to the availability zone that's running the application. So that way I'm not mounting volumes from the wrong place, maybe across a rack or across a data center or outside of the data center. We don't want that to happen. So this makes sure that it all matches. And then finally, the ingress route, this actually just tells it, hey, create a rule that says for Cockroach database in my domain, you know, create an ingress rule. So we will hit that in a second. So now back to, okay, apply Cockroach. If I can spell. All right, so the application is deployed, get pod. You're gonna see that it might say pending for a second. Creating. This is usually where I would stop, right? Like, hey, look, the storage is provisioned. But we actually, you know, I like to show more now. And so if we look back at the actual physical storage device, and I look for Traefik, you can see that it created 2 volumes on this array. And because the other one is set to the other availability zone, we have 2 volumes there. So 100 gigs each, 2 volumes. But that's, you know, in general, when you're consuming Kubernetes, you're not coming in and checking the actual physical device. Developers don't care. They just want to be able to say, I want storage, and now it's here. So we can actually check and see the application is running. Now it's not going to be ready until I do an init on it, which tells it to start the database. And once that's complete, one of these nodes is running. Should now be able to come over to my URL and I'm not telling a lie today. It takes a second to start up. What did I break? This is why I do live demos, so everyone can see that it actually is like real world. Not stressful at all to have this happen in front of everybody.
No worries, it's fascinating to watch.
I hope it is.
Could you tell us what you're looking for right now to kind of?
Well, no, so we should see a not 404, which,
Yeah.
you know, 10 minutes before this, when I did this demo the first time, totally worked. Could be my fault. Let's see. I'm gonna close some windows.
It's a very real world.
Yes. Oh, I will come back to this in a second. So we have that. You know, hopefully I didn't change something right before we started. And say .lab. Ha, I did change something. Okay, look at that. Pretend I didn't just spend 3 minutes trying to fix something I broke earlier today. Hopefully no one on the call has ever done something like that before. But yeah, so now you can see that I have, you know, I have Cockroach. I can actually see the demo. So this is the important part, and why I actually really like using Traefik is that now I can actually show the app and show the customer where it relates to the storage, right? So we can say, hey, here I have my 4 database nodes. Each one has 100 gigs of storage. If we look back here, capacity usage, right? They have a little bit of overhead, so it says 92.8, but like we can actually see that storage, and we can now do cool things with it, right? And now I can actually do things like scale it. And scale, stateful set, cockroach, replicas, and we have 4 now, so let's do 16. And you can see, we'll eventually see in the GUI, rather than me just going, hey, because I could come in here in the CLI and say get PVC. You can see it's creating all the new storage, and we'll start to see nodes appear here. And you can see there's, you know, as they start up, they'll start adding capacity. So from the storage side, which is, you know, the part that I care about, is like I'm now able to expand the storage and easily add it. But from the application side, I'm scaling that application and creating new live nodes to, you know, handle performance and all that fun stuff. So, and you can actually see it happening right before your eyes. So see there's more nodes coming in, and eventually we'll get to 16 and it's finished, it's ready to go. So hopefully that is, well, demo 1, right? And we, you know, that's pretty cool. I hope everyone thinks that's awesome. And oh yeah, they're all up and running. So we've scaled the application. Now there's obviously other things we can do here. Like if the customer is super interested in seeing data being written here, I will kick off like a workload, like a TPC workload that'll create database tables and all that fun stuff. That's where we get a little bit more boring, but I don't usually do that unless somebody asks me to. So now I'm gonna go back, and we're gonna go to the Go demo. All right, so we're gonna apply the MySQL portion. Oops. Hopefully no one else has ever had a typo in a demo before. And I'll show you what it looks like in here. So what's different on the, you know, MySQL is that it's not distributed. It's just a, you know, a single pod that attaches to one piece of storage. So what we're telling is like, hey, create this MySQL claim and create a brand new one with the pure block, which is pointing to my flash array here. So if we come back and say, okay, get PVC, right, there's the one that's, you can see this a little bit different. We didn't use the topology feature in this one. So I'm gonna say, take this name. If I come back to my storage device, we should be able to search this and see there's that 200 gig volume that was created, right? And you know what it's connected to is a host. So all that's done for you, like creating the host, creating the volume. You don't have to worry about that, but let's start up the rest of the apps. You can actually see it. So we're gonna apply the web front end. Well, I did that twice. All right. Once those are started, we can actually see there's the web front end, right? It's running. So we'll come in here and we will say http://go.dev.fsa.lab. All right, very simple web page that has a database behind it. But what we're going to do is we're going to show off a little bit of what it can, how it works, right? So I'm going to put in my name, got to register. It's a very fancy and secure app. It lets me do a 4-digit password. And we're going to log in. And you know, it's a notepad, which is, this is code that I borrowed from a Heptio demo. It's all open source, so I don't feel bad borrowing it. And we're going to drop some data into here. And just because I like putting the today's date in there. Right. So I'm going to save that, create a new note, put that in there, save. Hopefully, see, I'm in the Eastern time, so it's my local time versus UTC time. So for everyone, somewhere, you know, that's the timestamp on the server. But yeah, so we're up and running. The application's good, but you may have a use case where you're saying, hey, I want to take this whole app or this whole database and clone it and use it for dev or use it for something else, right? So that's what we, as a storage company, care about, but we want to be able to present this app in a new way. So what we're going to do is I'll show you this MySQL clone. And if we look at the bottom, instead of just saying, hey, give me pure block, what we're saying is give it to me from a data source, which is the MySQL claim. So it's going to take that exact MySQL claim that we're running right now and make a brand new copy of it. So we're going to do that. If I can type apply MySQL. See here that the clone is already made, so it really is that fast, right? Just a couple seconds. So we have this copy here, and if we come back to our array UI, see there's that new volume. It's attached to a different host. And you know, for the storage people out there, right, we're curious, like it actually still points back to that one now. If we delete, at least the way Pure works, like if you delete that original volume, this one doesn't go away or anything like that. It's just the way that we do those quick clones, it actually tracks that. In case you need to know, if we ever need to know, where did that originally come from? We can tell right there. So that's just something we do on the storage side. And then from your point of view, that's not going to change. Let's start up the web server for these here. There's the clone web servers. They're up and running. They're so thin, like, I mean, it's just a couple seconds. Of course, I've done this on this cluster before, so it's pulling the container images down. It doesn't need to because they're already there. But so we're going to go to a new URL. Because the way my lab works, I don't have it like generating certificates for the web app. So obviously you would do that in your own environment, but our firewall, I can't do a let's encrypt because the way our firewall blocks inbound traffic. So, so yeah, so here's my app, it's up, but since this is a clone, right, I should be able to come into this new version of the application and still see the same data if I've done everything correct today, which is always an adventure. So my account's still there, so that's good. So it means that, you know, the database copied correctly. And there's my data that I created earlier, right? So 1229 on my time. Yeah, so that's the demo. Is there any questions or any comments or anything completely not related that you want to say?
So what does this look like for you in your workflow? Like a company reaches out to you and wants to see Pure Storage, and then you bring this up? Yeah.
Yeah, so the way that we kind of work is, you know, obviously Pure, we're you know, around the world. Like technically I only kind of help in North America, but since there's not like hundreds of Kubernetes people running around, I help in Europe, I help in Asia too, right? And so, yes, a customer comes to us. Usually it's because they're like, hey, my CIO said I need to use Kubernetes. How do I do this? And so I show up and I show this to them, right? And I show them how it works. And hopefully, like by showing them the app, like and how it actually does, it can show them, you know, they can at least connect it to whatever they're doing. Because they may not be doing this exact app. They may not be doing Cockroach database, right? But they can actually see, you know, connect the concepts a little easier to what they're going to be doing for that reason. So I see a question in the chat.
Totally.
URL for my GitHub. And yes, it does have the Traefik configs in there. And I'll send it to Patricia too, but I'm going to put it in the chat
I'm gonna steal this and put it. We'll send you the video, the video after, and I'll put this in the email.
So it's under here, and then it should be Traefik, right? Because I just updated it a little while ago with some new things.
I mean, I'm sorry, but I'm also on a loop about how you said tacos versus hamburgers, and I'm trying to decide how you would decide that too. But
well, yeah, see, it's topology, right? We'll let the Kubernetes scheduler decide.
oh, yeah.
But no, in this demo, that just makes it, I think it's more fun to say that than East and West. I used to always go East versus West, just kind of boring.
Yeah, yeah.
So.
It's great to see some of you in here. I recognize names, so thank you very much for coming. And Michael, thanks for that question. Anyone else have any questions or want to share the experience that you have if you're also demoing apps and things? Or questions about Pure Storage? Otherwise, what happens now is we will produce this video and then send it to you. It will also go up on our YouTube channel and on our website. So
awesome. I'm glad the part that I broke will be on there too. So everyone knows this wasn't pre-recorded. I do screw things up.
Well, I mean, it's a great real life example, and I will say we forgot to pray to the demo gods first.
It happens, right?
It happens. Yeah. Yeah, well, I am super thankful to you, John, and thank you to everyone who attended today. And I hope that everyone is doing well and staying very positive right now. And it's cool to do some virtual stuff together. And I guess you can find John on Twitter too. Same name as his GitHub handle, and then at Pure Storage. And that's, yeah.
There's more info here if anyone's. Yeah, so there's more info. And obviously, if you have more questions, you can find me. Yeah, I have a blog, I have a GitHub page, and if you find me, John at John_2VCPs on Twitter.
Yeah, throw him the hard questions when no one's looking, because I'll be looking. Cool, John. Thank you so much. And I always do a virtual fist bump, of which everyone usually leaves me hanging. So thank you for not doing that. And you gave it flair. So
yes.
Thank you everyone for coming, and we'll see you online.
Definitely.
Okay. Ciao,
Bye,
ciao.
everybody.
Bye.